overlap of atomic orbitals. Overlap of atomic orbitals. Overlap of atomic orbitals. Overlap of atomic orbitals. Okay. Overlap of atomic orbitals. Overlap of atomic orbital. Okay. In formation of covalent bond, overlap of atomic orbitals are of three types. Overlap are of three types. Okay. First SS orbital. SS overlap. SS overlap. SS overlap. Second, first is SS overlap. Second is SP overlap. SP overlap. SP overlap. Second is SP overlap. SP overlap. Third is PP overlap. Third is PP overlap. PP overlap. Third is PP overlap. Okay. There are three overlapping presented here: SS overlap, SP overlap, and PP overlap. Okay. First, SS overlap. SS overlap. SS overlap. SS overlap. Okay. S orbital is spherically symmetrical. S orbital is spherically symmetrical. S orbital is spherically symmetrical. Hence, S orbital can overlap in all directions. Thus, the bond formed due to overlap of S orbital is non-directional. Formation of S2 molecule is an example of SS overlap. In the formation of S2 overlap, one s orbital of one H atom overlap with that of another H atom, resulting in the formation of covalent bond. This is as shown as like. This is a hydrogen atom first plus this is hydrogen atom second. Okay. 1s1, 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 1s1. Okay. After form of molecule, this hydrogen atom is converted in a molecule. This is after overlapping. Okay. This is after overlapping. Okay. Overlap covalent bond. Overlap covalent bond. This is overlap covalent bond. Overlap covalent bond. Molecular orbital. Molecular orbital. Molecular orbital. Molecular orbital. Okay. This is a light. H bond. H covalent bond H. This is sigma bond. This is sigma bond. This is sigma bond. Sigma bond, okay? Formation of H2 molecule. This is formation of H2 molecule. H2 molecule, okay? Formation of H2 molecule. S overlapping. S overlapping. S orbital is spherical symmetrical. S orbital is spherical spherically symmetrical, okay? Hence S orbital can overlap. Hence S orbital can overlap. Hence S orbital can overlap in all direction. All direction, okay? Thus the bond formed due to overlap of Thus the bond formed overlap due to overlap of S orbital is non-directional. Overlap of S orbital is non-directional, okay? Non-directional, okay? Formation of H2 molecule is in an example of S overlapping. In the formation of H2 molecule, one s orbital of one H atom overlap with that of another H atom, resulting in the formation of covalent bond. This bond is called sigma bond. This bond is called sigma bond. It is symmetrical about the nuclear axis. Okay? Second point. sp overlapping. Second point. sp overlapping. Okay? Second point. sp overlap. Overlap of s orbital of one of the combining atom with the p orbital of the other is called sp overlap. In this type of overlap, s orbital overlap with any other of the three p orbitals. This type of overlapping can be illustrated by the formation of hydrogen fluoride and hydrogen chloride and water and ammonia, okay, etc. A molecule of HCl or HF is formed by sp overlap. The electronic configuration of fluorine atom is 1s2, 2s2, 2px2, 2py2 and 2pz1, okay? A molecule of HCl and HCF, okay? A molecule of HF and HCl formed by sp overlap. sp overlapping, okay? The electronic configuration of fluorine is 1s2, 2s2, 2px2, 2px2, 2py2 and 2pz1, and that of hydrogen is 1s1, okay? This is the electronic configuration of fluorine and this is the electronic configuration of hydrogen. Okay. Fluorine requires 1 electron for inert gas configuration. Fluorine required for 1 electron. Fluorine required for 1 electrons for inert gas configuration like neon. Like neon, where is hydrogen also required 1 electron. Hydrogen is also required 1 electron. Hydrogen is also required 1 electron for achieving stable configuration like helium. Like helium 1s2. Here hydrogen and fluorine atom have half-filled orbitals in their outermost orbit. So hydrogen 1s1 and fluorine hydrogen 1s1 and fluorine 2pz1 when H atom approaches F atom, the 1s orbital of hydrogen overlap with 1s orbital of hydrogen overlap with 2pz atomic orbitals of fluorine and form a molecule of HF atom. Form a molecule of HF atom. How to? This is a fluorine and 2pz1 in the direction of Z plus. This is hydrogen atom. This is hydrogen atom H1S1 and the overlapping is a hydrogen atom H atom and this is P atom, P orbital. This is P orbital of fluorine. This is hydrogen fluoride HF. Okay, hydrogen fluoride HF. This is the overlapping point. Okay, R. This is as like this. This is as like this. SP overlapping. SP overlap. SP overlap. SP overlap, and this point is also known as nodal plane. This plane is also known as nodal plane. This also is known as nodal plane. Nodal plane. Okay. Nodal plane. Formation of HF molecules. Formation of HF molecule. Okay. Formation of HF molecule. Hydrogen chloride molecule. Here the bond formed is known as sp bond. Here the bond formed is known as sp bond. sp bond. sp bond and sigma bond. sp bond or sigma bond. Sigma bond. Sigma bond. And two sigma bond are formed respectively. Two sigma bond are formed respectively. Two sigma bond are formed respectively. Okay. So sp overlapping. Overlap of s orbital of one of the combining. Overlapping of s orbitals. Overlapping. Overlap of s orbital of s orbital, overlap of s orbitals of one of the combining atoms of one of the combining atom, one of the combining atom with the p orbital of the other, with the p orbital of the other is called sp overlapping. It's called sp overlap. Okay. In this type of overlap of s orbital of one of the combining atom with the p orbital of the another is called sp overlapping. Okay. In this type of overlap, in this type of overlap, s orbital overlaps with s orbitals overlaps with any of the three p orbitals, any of the three p orbitals, This type of overlapping can be illustrated by the formation of hydrogen fluoride, HCl, hydrogen chloride, H2O, water, and ammonia, NH3, ammonia gas. Okay, NH3. Okay, it is. And next is PP overlapping. PP overlap. In this type of overlap, p orbital of one atom overlaps with the p orbital of the another atom. In this type of overlap, the p orbital of one atom, the p orbital of one atom, overlaps with the p orbitals of another atom, p orbitals of another atom, This type of overlap can take place in two ways. This type of overlap can take place in two ways. Okay. First number, coaxial. Coaxial are head-on overlapping. Deep-wise. Sidewise are collateral overlapping. Sidewise are collateral. Collateral overlapping. Okay. When two p orbital of different atoms overlap, then it is called pp overlap. One p orbital can combine with another p orbital in two ways. First is coaxial. Coaxial or head-on overlap. Head-on overlap. Okay. Head-on overlap. Or end-on overlapping. End-on overlapping. Okay. There are coaxial or head-on overlapping or end-on overlapping as like this figure. Is px orbital. This is px orbital and this is px orbital. Okay. This is px orbital. Because this present here on the axis of p, okay, and after overlapping, as like this figure is okay. After overlapping, head-on overlap. P orbital and p orbital. This is head-on overlapping. Head-on overlap. This is head-on overlap. As like this is like this, okay? Nuclear axis. This is nuclear axis. Nuclear axis and this is nodal plane. This is nodal plane and equal axis overlap. This is equal axis overlap. Okay. P orbital is directional. This type of overlap results by combining up to such atoms whose p orbitals are available for covalent bond formation. P orbital is directional. P orbital is directional. This type of overlapping results. This types of overlap results by the combination of two such atoms whose p orbitals are available P orbitals are available for covalent bond formation. Covalent bond formation. In this overlapping takes place. In this overlapping takes place. In this overlapping takes place on one axis. Okay, on one axis. One axis means that the line joining. One axis means the line joining the nuclei and the direction of overlap. Line joining the nuclei and the direction of overlap. In the direction of overlap are atoms are same. Okay. Formation of fluorine, chlorine, bromine, etc. Formation of fluorine, chlorine, bromine, etc. Are examples of PP coaxial. Overlapping. Okay. Formation of fluorine molecule. Formation of fluorine. F9 equal to 1s2, 2s2, 2px2, 2py2, 2pz1. Okay. This 2pz. This 2pz orbitals overlap on same axis. The bond formed by pp overlap is a sigma bond and is symmetrical about the internuclear axis. The coaxial overlap of pp orbital in F2 molecule is shown in the figure as like. This is a like. So this is a like this. This is not overlapping. Okay. This is not overlapping. Okay. This is on x-axis. This is on x-axis. And this is on x-axis, and this is on y-axis, and this is on y-axis. Okay, this is overlapping point. 2px, 2py, 2pz, 2pz. Okay, 2pz. Okay. Sidewise are collateral overlapping. Second is sidewise. Sidewise are collateral overlapping. Collateral overlapping. Okay. In this type, both p orbitals, py or pz, combined sidewise are collaterally. The molecular orbital found by the sidewise overlap is called pi molecule orbital. Pi molecule orbital or pi bond. Okay. In this type, both p orbitals py or pz combine sidewise or collaterally. Okay. Collaterally. The molecular orbital found by the molecular orbital formed by the sidewise overlap is called pi molecular orbital. Is called pi molecular orbital. Pi molecular orbital. Okay. Or pi bond. The bond thus formed pi bond is comparatively weaker than sigma bond. Pi bond is weaker comparatively than sigma bond. This is sigma bond. Okay. This is because the existence of overlap. In sidewise overlap is smaller than coaxial overlap. Okay. The overlapping in pi bond takes place at 45 degree on the molecular axis. The overlapping in pi bond in pi bond takes place at 45 degree on the molecular axis. At 45 degree on the molecular axis. Okay. The overlap is partial and it is not a direction of line joining the nuclei. Due to partial overlapping, pi bond is weak. Due to partial overlapping, pi bond is a weak bond. Pi bond is a weak bond. The PP sidewise overlapping as shown in this figure as like this. This is this is two p orbitals, okay, two p orbitals, nuclear axis. This is nuclear axis, this is nuclear axis, nodal plane, and this is nodal plane. After sidewise overlapping, this figure has like seen this. And like this, okay? This is plus. Sidewise overlapping. This is sidewise overlapping. This is sidewise overlapping. Sidewise overlapping. Sidewise overlap of two p orbitals. And this is found pi band, okay? Pi band. I like this. Pi band, okay? Pi band. Pi molecular orbitals. Pi molecular orbitals, okay? This is positive and this is negative. Pi molecular orbitals, okay? This is pi molecular orbital, okay? Formation of oxygen molecule, okay? The electronic configuration of oxygen atom is as like O8 equal to 1s2, 2s2, 2s2, 2px2, 2py2, 2py1, and 2pz1 and 2pz1. Formation of oxygen molecule, O2, O8, okay? O8 equal to 1s2, 2s2, 2px2, 2py1 and 2pz1, okay? When two oxygen atoms combine each other, two p orbitals having unpaired electrons with opposite spins overlap. The 2pz and 2pz overlap along their intermolecular axis to form a sigma bond, while 2py overlap sidewise to form a pi bond. Hence, the two atoms in oxygen nuclear molecule are bonded by a strong sigma bond and weak pi bond, which is shown in the form of electron cloud above and below the plane of oxygen atom. Okay? How to? This is a light. Okay? This axis is x-axis and This is Z axis. Z axis, and this is Y axis. This is Y axis, and this is Z axis. Okay, this is Z axis. This is Z axis. Sidewise over head on overlapping. This is head on overlapping. Head on overlapping. Okay, head on overlapping. This is head on overlapping, and this is sidewise overlapping. This is sidewise overlap. Sidewise overlap. Sidewise overlap. Okay, as like this figure. Two bond present here. Sigma molecular bond. Sigma molecular bond and pi molecular and pi okay, and pi moleculars. Okay, pi moleculars bond and pi moleculars bond and sigma. This is plus, this is plus. Oxygen, two bond present, pi bond and sigma bond, pi bond and sigma bond. Okay, formation of nitrogen molecule, formation of nitrogen molecule. Okay, formation of nitrogen molecule in next term. Okay.